This is my lab 3, the black hole lab. The purpose in this lab is to analyze the motion of a star to find the net force on the star and also to use that information to estimate the mass of a black hole that this star is orbiting. So we were given a data file, star data, to download with the position data for the star, the mass of the star, and the time step or change in time between each position reading. And then we were to use the VIDLE program to analyze the star's motion and be able to use that information to find the mass of the black hole. So in VIDLE, use the starter program, and a few things that I had to change relative to my system was the mass of the star had to be added in, and changed from what it was initially to be accurate. So that was done. Same thing with the delta T, changed to the appropriate amount. Also with this, I had to make sure that the correct star data file was being used since it changed names when I downloaded it. Also had to make sure that the x and y components of velocity were both computed correctly, so that information was added in. In the calculation loop, it was necessary to have the initial velocity as well as the final velocity and the initial position and the final position, position, momentum vectors, to be able to then use that to calculate delta V and delta P to be able to calculate Fnet. So Fnet is equal to the change in momentum over the change in time. In addition to that, since this is a motion in a circle, we had to calculate the parallel, Fnet parallel, and Fnet perpendicular, or delta P divided by delta T parallel and delta P divided by delta T perpendicular. In addition, I also added in information to help me calculate the mass of the black hole with the gravitational constant added, as well as the magnitude distance. And then for calculating the black hole mass, use the equation of Fnet times the distance or the radius squared divided by our constant g times the mass of the star. And that information gave me the mass of the black hole. Also, the appropriate scales for each arrow for my Fnets, and had it print out that information. So I'm going to run a little bit of the program for you so you can see what my results were. So you can see my 3 arrows, my yellow arrow, my Fnet, my blue arrow is the Fnet perpendicular, and the black arrow, the Fnet parallel. I don't have a lot of time, so I'm not going to run the whole program, but you can see the output here. And when I did that, at the end, it did give me the mass of the black hole being 3.21 times 10 to the 31. And so my computational model was accurate in helping me determine that mass of the black hole. Now, as far as what this means and whether or not Fnet perpendicular, Fnet parallel, and Fnet are different from delta P divided by delta T in each of those cases, I would say that one of the things that we notice with this is, of course, it's moving in a circle, so there has to be acceleration, which means there has to be a change in momentum, and that circular curved motion is caused by the fact that the Fnet perpendicular is not equal to 0. And so a change in the momentum gives us a change in the Fnet. And the change delta P divided by delta T would be caused by those forces acting on this system. As far as if we replace this black hole with another one of a different mass, as long as the motion of the star remained unchanged, we would not be able to find that value for the new mass because everything would look the same. Only if there was a change in the motion would we be able to tell that. Thanks.